呀，这是开的，一会儿你先给关上，这个关上。
So we have 14 for the final presentation. Here we go. So for those of you who clients in the room, each team has 15 minutes. They'll give us a sense of what they've done this semester, what they've accomplished in like 5 minutes Q&A. Producers keep an eye on me for time and Q&A. And we'll start with real empathy, then we go with, who's after that? Real empathy, inklings, then Molten core, then impression for this day. So real empathy, whenever you are ready.
Okay, hello everyone. Welcome to the final presentation from Real Empathy. So let's talk about the team. We have like fantastic 4 members here. We got Martin, Shanshan, Bella, and me. And we lead by our amazing faculty, Ricardo and Ruth. And we always have our strong support from our client, Nadia, Elvira, and Paula. So talk about the clients. Let's talk about what clients need. So they want a standardized patient program. It's like a interview stimulation. It's like a lecture for training their second-year medical student to learning how to show the empathy correctly and properly during the conversation. So that is our clients, what they did right now. They hiring some volunteers and training them, and then play the patients for the interview stimulation. And also for the whole training process, they will be the advisor will observe the whole process and give some grade. So this is the mission our clients bring to us. They want to build a virtual patient in the VR world with the AI chatbot feature, so it can talk to the patients, it can test the patients, and then provide some data to the advisor for the future empathy evaluation. So let's walk through about the whole experience so you can have a better idea to see how this experience look like. We prepared a short demo here. So student going to put on the VR headset, and suddenly you will sitting in the clinic room, and then you're going to talk to the patient.
Hi, how are you?
Hi, Doc. How are you?
I'm good. How can I help you today?
I'm here for my urgent visit, but I have some concerns.
Okay, can you tell me more about the concerns?
Okay, so this is just a brief idea about the experience. A total training process probably take you 4 to 5 minutes to finish it. And after that, we will show a dashboard on the monitor and also in the VR world. So those are like showing some like score or performance and some data we're collecting during the whole process. So advisor and the student can base on this result to have like further discussion to see how to improve their behavior. So you can see there's like the 3 many-part technique we use during the whole process about like the VR video, AI chatbot, and data platform. And later I'm gonna hand it to Bella to talk about more about the VR.
Thanks, Leo. So why do we need virtual reality? The standardized patient program for now, current solution is to hire actors and actresses to play the patient. And the problem with these solutions is that it is hard to provide one-on-one training and it costs a lot. Especially during COVID time, it is even harder to hire actors. So our client want a reusable solution for this program that can provide better practice for the students. And a virtual reality can provide such an environment and also free the limitation of space. And we are using Oculus Quest 2 for its standalone feature that it does not need to be connected with other devices, and it also has a built-in microphone that allows us to recognize what our users said, that it can provide a better immersive experience. So we chose 360 video over 3D animation for our environment, that we want to avoid the uncanny valley effect, and also since our project is more about empathy, we thought of using real person could be a better way to relate. For filming and editing, we started with using ourselves as actors and testing the conversation tree in our clinic room. That in the meantime, we found out several problems, such as noise issues, lighting issues, and the change of position of our actors. So we must get control of the environment and make sure nothing changes, that it does not break the immersive feeling. Before the official shooting, we went ahead to the clinic room where we will be filming for our final clips. We tested the space and also measured the place to make sure everything stays in the same position. During the official filming, we used duct tape to mark the place where our actors are going to sit to make sure the position does not change. For our takeaway, during the several times of filming, our scripts changed from short sentences into long stories, each for positive, neutral, and negative stories. That we did have a more official script for our story, for the actress, and also adding additional guiding and hint clips, such as, can you say that again? Those kind of clips will guide our users back to the conversation if their words has not been recognized. And during directing, for the immersive feeling, we've thought of several ways to enhance it, such as we set a still pose for our actress that at beginning and the end of each sentences, the actress will have their hands across on their legs to make sure the position does not change even after editing. For our editing part, we used the cross-fading technique to avoid the jump cut issues. And from our playtest and feedback, most people said that the transition between clips and clips are better and smooth now. Next, I will hand it over to Martin to talk more about our AI chatbot.
Thanks, Bella. So in HAPS, we have talked about our pipeline of building conversation system. We use IBM Watson speech-to-text services to convert players' audio input to text, and then send that text to a voice flow, which is an online conversation tree building tool for us to drive an AI chatbot. The AI chatbot will compute the corresponding patient's output, and then send that over to the Unity to display the correct 360 VR video to the player. But even though we have this pipeline figured out, we still have some challenges ahead of us. This first one is when the background is kind of noisy or the player audio is a bit muffled. We eventually tweaked the noise canceling parameters in the IBM Watson API and also wrote a little bit pulse handling script to mediate this problem. The second challenge is how we can correctly understand what the player is saying. And we are using a feature in the voice flow called intent. The idea behind the intent is that different expressions can have the same intentions. For example, the player can ask the patient, what brings you in here today? And the player can also ask the patient, how can I help you today? These are basically saying the same thing. We just ask the patient's purpose of the visit, but they sound different. So in order to have our system understand these two expressions have the same intentions, we will create an intent for it. And in this intent, there's a field called utterance, which is basically we put all the possible predictions and expressions that have the same intention into this field. And after the training, the natural language processing model will understand how to correctly understand that. After we have an intent, we're going to use a button block. This is also a feature provided by VoiceFlow. This is basically a branching block that characterizes the patient's input into several different intentions. And different intentions will have different responses. Besides different responses on different intentions, we also want to explore the possibility to have different responses based on some long-term metrics, such as overall empathy level of the players throughout the whole experience. And this is where we use another feature in the voice flow, which we call variables. Variables are the thing that record the players' related information throughout the whole sessions. So here, we create a variable called empathy levels. And empathy level will change depending on different intentions that has been detected. Just a short example is if the player is talking to the patient in a less empathetic way, the overall empathy level will be down by 1 in the current block. And if the player is talking to the patient in a more empathetic way, then the empathy level will go up by 1. This also helps us generate the final data report at the end of the experience that Shanshan will cover later. The fourth challenge is come from the structure of our experience. It is a pretty linear experience. It has a main flow where the patient will talk about her concern over the blood pressure and how her previous miscarriages had led her to be this kind of concern. But other than that, we also have some small talks where the patient and player can discuss some medical histories, the readings on the blood pressure, etc. These small talks. And these small talks can basically happen anytime in a conversation, and we need to find a way to guide the conversation and the player back to the main flow. So here we start another variable called story progress and record how far the player has gone in the main flow. And after the small talks, we will jump back to the correct stage in the main storyline so that the whole experience will look smooth. Basically, at the beginning of November, we have figured out the solution to all these 4 challenges. But there's one more important thing for us to do, and that is to keep playtesting and tune our conversation tree. Because for our own experience, every time after the playtest, we can always find something unexpected that should be included into our conversation tree system. So starting from November, we have been constantly playtesting with ETC students, ETC faculties, and of course, medical school students. We had held over 20 playtest sessions. Our number of intents in the conversation tree have increased by 60% from 14 to 23. Our total number of utterance, or in other words, the prediction, the possible expressions the player can make have actually doubled. And we have also increased the possible small talks from 2 to 7. And the total number of blocks in the conversation tree, which basically represent the complexity of the conversation tree, have increased by 50%. So compared to the start of the playtesting sessions to now, we can comfortably say that our conversation system have been getting more robust and more complete. Next, I'll hand over to Shanshan to talk about our data review.
Thanks, Martin. So next, I will talk about the data review. So just like our team said before, Real MC is an initiator of the training process. So providing the final report for the students to review is as important as the training experience itself. So since we want to know like how to understand, how to evaluate the data for the MC. So we got some the reference from the University of Pittsburgh's standardized patient program. And we also do some the research about the worldwide using the MC scale called the JSE. So according to those research, we designed the 5-stage we design our experience under the 5-stage MC training structure. And this structure will help the students and professors to review the training process in organized. So here is the data, how we record and we store it. We do the change of the MC level, average reaction time, and also words counts of the response. So in order to visualize the data before we saw into our final report, we design a dashboard for the user and the advisor to review. And in order to make the dashboard is accessible for them to use. So we use the information architecture to make the dashboard more organized. So here is the overview page. In this page, we show the total MC of the user got, so they can have an idea like about their performance. And also, we show the percentage of the category of their response, so the user can like know how much positive they made. Also, the user can review the change of the MC level with the timeline, so they can help them to better understand and analyze their performance. So next is about the detail page. In the detail page, the user can see more details like what exactly they said in the performance, and also the result of the response is positive or negative. Yeah, that's all about the data. So next, I will pass to the Neil talk about the conclusion.
Yeah, thank you, Shanshan. So let's talk about like extendability. So just imagine if you want to build another scenario based on this whole experience process. So for each iteration, you probably take 1 day to film it. In our case, we take like 3 to 4 hours to film like all clips for like 5 minutes long experience. And after that, you need 2 days to do the post-processing, including noise canceling, editing, and put it into the Unity. And we suggest you at least did like 10 times of the playtest. That can help you to collect some data and input to tuning your conversation tree. And this is our estimation for each iteration. If you want to build a whole new scenario, you probably need to take 3 to 4 iterations to finish the comprehensive scenario. So talk about lesson learned. What we're doing well and what can we do better? So about the filming part, we do it pretty well. Like we build a whole rundown, so that can help us to improve our efficiency when we film it, and also make sure we miss no detail when we're filming in the scene. The thing we should do better is about we need a better directing. We lack of this experience before. So what we learned, like a better directing can help actor and actress to perform better and easier when we filming them. And also for the VR and AI chatbot, we do pretty well about like extendability. So you can see we build up like an easy extendable pipeline, and you can easily to tune in a conversation tree with the GUI interface on the voice flow. The thing should do better is about like detection. Detection latency causes some like unsmoothness when you switch in the cuts, and also we miss some like tune detection or pressure detection. That could be some potential in the future. For the design part, we're doing pretty well. A lot of research, and we think like we locate ourselves at the end in a pretty good way. It's like an initiator. It's like an exam to provide the data for the advisor. But we should consider data in the early stage so we can have like a better data generation. So just review this semester. We start with an out of scope and ambitious vision. I think that's totally good. I mean, that's a classic ETC project, right? We want to make the impossible become possible. So then we pivot our scope, and then we revise our vision. At the end, we end up with the high fidelity, smart patient, like with empathetic behavior data. So thank you. This is all the story about real empathy. I hope you enjoyed it. And once again, we want to thank you, our faculty and our clients. Thank you. Yeah, so any question?
Hello, everyone. Do you have a mic now? Okay, so now that we both have mics, could you go back to the slide where you talked about the different parts, the little mentions and stuff? There was a slide where you broke all that down. Could you show that for a second? Back up, back up, back up. A little bit further. There was like one where you listed, keep going. Well, you passed it, you passed it. Anyway, I don't know what those things were in that list. I don't remember you defining those different things, and so I was confused about them. And without the slide up there, it's hard for me to point to that. But I noted it in my notes, my feedback to you. So unless you can find the slide, it's hard for me to ask you the question. Sorry.
Sorry, I didn't really understand your question.
I know. Unless
Okay.
you can pull, without me like driving the slides, I need you to get to the slide to really ask my question so I can point to the things I didn't understand. So sorry, but I noted it in my feedback.
Okay.
any other question? Thank you.
You work with video, which is understandable. Can this work as interactive video on a website? Do you need a virtual reality device?
Sure. So Mike's question is basically, can we extend it to a website-based video player experience, right? Okay. My answer would be yes. So the reason why we choose virtual reality as a media is, first of all, is our client's requirement, because they think it will provide a better immersive experience to the player. And because eventually this is going to be an experience happening still in the medical school. Portability is important, but it is less of a priority. So converting to a web-based has this like advantage of like being able to for the students to play at home and or like anywhere like in the university.
Yeah, I just want to second up this Martin's answer. So in our observation when the play testing, when people put on the VR headset, usually they really feel the isolation in there. So suddenly they just like feel they are lonely with the patient, and sometimes they freak out, like make them a little bit nervous. But we thought that's a perfect setting for training the students, so they can see there's no one can helping you, only you have to dealing with that patient in a properly and correctly way. So I hope this answered your question.
Time for one more.
Oh, Brenda.
So I'm not even sure where to begin with this. I'm not sure where to begin with this question. It's about intonation. You mentioned it several times. How did you measure empathy with intonation?
Yeah, so Brenda, your question is about like how we detecting empathy level without the tone detection, right?
I'm asking, did you detect empathy level based on the semantics, on the words themselves, or on how those words were said?
You want to answer the? Okay, you can answer the.
Yeah, okay. So as we said before that we set intent in our voice flow. So for each intent, we have a standard for the emphasis level. For example, ask positive or ask negative. And
So give me an example of ask positive and give me an example of ask negative.
Yeah, we have some reference from our clients. For example, for ask positive, it could be a way like, I know it is your 30-week visit, and how can I help you? For ask negative, I can ask, why are you here? What do you do here? So there are different references for us to put the different answers into the different intent,
Okay.
and that will give you the score.
We can talk about this later, but I could argue that you could say either of those two phrases in a positive way or a negative way.
Well, it is a choice of words, and we do believe, for example, when you say, why are you here, is a definite negative response.
Yeah.
So, yeah.
I just want to second up. So, like, we really take detecting some like keyword. You shouldn't say that. You didn't want to mess it up. For example, you shouldn't just like say, just relax, drink more water, don't worry. Those were totally negative word. We will be detection for those keyword stuff. And also the one thing we also mentioned is about we just showing those report and we just record down like what the student exactly say, and showing this report with the advisor and the grader. So they can usually, I mean, the main point is like after this experience, they are based on those report and have further discussion. So the advisor, they witness the whole experience as well. So they can just based on this, those recording and give more like feedback and to improve to the student's behavior. Yeah.
All right, that's time.
Yeah, that's time. Thank you, everyone.
Good afternoon, everyone. Here is Team Inklings, and we are the year-long animation studio. And we have 5 team members, including 2 programmers, 2 artists, and I'm the lead producer. And here's our 4 faculty advisors. They are John, Ruth, Ricardo, and Mo. The goal of this project is to deliver 2 final deliverables. One is a motion captured animated film called Inca Lives, and the other one is a prepackaged for the future team named Seed. And let's check about our final production. Thanks for watching, and Claire gonna talk about our art and challenges.
Thank you, Gloria. So as you have seen, our animation is made from a first-person perspective. And that being said, we don't have a full character that is rigged and animated in our final product instead of a pair of hands. But that doesn't mean we don't have a full character who is standing behind the scene doing all the magic and also having her own thinkings. So how to deliver those personalities of the character as well as the world setting has been a really great challenge for the team. So in order to solve that, the first thing we did was creating a character sheet that covers all the personalities of this character so that we will have a good reference to go to when we need to decide what kind of actions or movement that a hand will have when the character runs into a certain situation. We also put on some details, for example, the dark nails on the hand, just to give more clues of what kind of character she is. And the desk area is also set up as a mask, also as a part to show her personalities as a person who will try to take a shortcut while learning a new magic. And another great art challenge, as well as a part of tech challenge the team has been working on, is how to set up a rig that is workable for lip motion, the equipment that we use for motion capture. We first rigged the hand just in a very traditional animation way. We placed the joint along the mesh, but it just didn't work out because the rotation of the joint will just go to a different direction than we expected. So we start to figure out what kind of features is needed in order to qualify the rig workable for lip motion. One thing we did was comparing the default hand and a rig that offers by lip motion and the hand and a rig that we purchased online, which is totally workable for lip motion with our own rigs. And one thing we noticed that when we set the rotation of the joint on the finger joints to 0, it will just give us a really straight skeleton, and those skeletons just like parallel to each other. So we assume that's something that we've been missing. And we use this to create our own rigs, our final rigs, which finally is workable for lip motion. We also plan on document it and pass it to the future team because we didn't find any resources online when we were trying to solve this problem. And now I will pass it to Neil to talk about tech.
Yeah, thanks, Claire. And I'm going to talk about some challenges we have for the motion capture integration. So motion capture is one of the most special features in our project because we use them to make all the hand animation of the main characters. And we use lip motion as our motion capture devices. But that becomes one of the challenges because lip motion is not designed for animation making. And we have to explore how to use them without a tutorial and the demo and by trials and error. And so and I'll go through the whole pipeline step by step. So the first step is blueprint data handling. So this is part we use on Unreal to grab the data from lip motion and use those data to control the hand animation. For the challenging part of this is that it needs to cooperate with the art, the model that Claire just mentioned. Whenever there's a change in the model, the blueprint needs to adjust according to the change so the code and the model can fit with each other so the final hand can look correct and nice. Once we have the correct tool, we can start to act and recording. This part is not easy as well because none of us has performing experience and we have to consult students from drama school to learn how to express feelings with only hand gestures. The other challenge would be that the lip motion has a limited detecting space and it has unstable detecting accuracy for some hand poses. So when we are doing our acting, we need to design specifically what kind of motion we can include in our final film. So it's simple enough for lip motion to work, but also tell the story clearly. So the third step is post-processing. We do not have this step before. Before, we just put our raw animation into our film directly, but later we find out that the unprocessed animation is jittering, and if we put it directly, the whole animation will be very unnatural and be very distracting. So we decided to put the animation back into Maya and filter it to make it more smooth and natural so it can look nice in the final film. And finally, when we put the animation back into the sequence, as you can see, there's a lot of hand interaction between the hands and the object in the world. But when we are acting and performing in the real world, we cannot see those real objects, virtual object. So there will be always a different position difference between the final hands and our original hands. So we need to adjust again in our Unreal both the object position and the hand position to let them fit each other and look nice. And next, I'll pass it to Z to talk about other challenges in our pipeline.
Thanks, Neil. So I will talk about the challenges that brought by our pipeline. So the main challenges that brought by our pipeline is the dependency list. We have such a huge dependency list that is making it so hard to do iterations, especially in the later half of the semester. So let's take a look at this. So the first, on the on the left side is the hand animation. Hand animation is on the top of our list, which means like each little change in the hand animation may cause a chain effect that we have to change everything after that. For example, object animations. Object animation are the animations you've seen. For example, the moving of the magic ball, the pen, and the ink ball, and etc. The third one is camera animation. So camera animation is also what we've done in the Unreal Engine using the keyframe animation system, and it is closely related to other objects. And the fourth is Adobe Premiere. Adobe Premiere is the place where we do the post-editing and also editing all the audio files. So let's walk through two examples. Example one is the shot where our main character takes things out of the box. So this shot is particularly difficult because, as Neil has explained, the hand-box interaction is really tricky and it's hard to make it look smooth and natural. So we have experimented a lot. We have done a lot of shots for this. So whenever Neil hand me a new hand animation, what I have to do is, for all the highlight objects, I have to readjust the animations to match with the new hand animation. For example, I have to readjust the animation for the magic ball so it follows the finger properly. And I also have to readjust the animations of the book to follow the magic ball, and etc. And after all that has been done, I have to also change the camera animation so we can make sure that the thing that we want the audience to focus is always around the center of the screen. And after all that, we got a video out of the Unreal Engine. Then we have to put it into the Adobe Premiere file and readjust the audio files to the correct time and also do some post-editing, such as speed up the whole shot for about 30%. The next example is the last shot where you've seen the 2D animations drawn upon the 3D scene. So the pipeline here works like this. Instead of rendering out the video, we use Unreal Engine to rendering out frame pictures. Then we take all the frame pictures and pass it to our 2D artist Ching to let her draw upon it. And the workload here we're talking about is around 1,000 frame pictures, which is really a lot. And I believe you can imagine it is really hard to do iterations here because in our case, we're using 24 frames per second, which means 1 second of change will lead to 24 new frames for Ching to work on. So that is a lot. And thus we noticed there are places and spots that we can improve and polish. But this is the best we can do for the short time frame. So talking about the lessons we learned, first, we have to make decisions and settle down our pipelines as soon as possible, because after that, we can then list out our dependency list and prioritize our tasks better. And also communication is really important, because with such a huge dependency list, every update matters, and keep our teammates and faculty informed can always help us do better on the task management. And the third is to seek advice, since there are a lot of new things that we haven't really touched before, and gaining some knowledge from the experience can always help us improve and polish our product. And next, I will hand to Ching to talk about prepackaged.
Thank you, Z, and I'm going to talk about the prepackaged for the future team. And these are the storyboards, so we pitch from a lot of creative ideas and finally decide to deliver this story to the future team. So this is a story about an inevitable tragedy that caused by a crazy and rigid scientist who is so desperate for success and insisted to executing a dangerous experiment and finally lead to everything just lost control. And so the story is not linear, and the audience may not know where the story is going at first, but as the time passes, they may collect clues from the pieces in the story and finally restore the original whole story. And these are the environment concept reference we set for the next thing. And as the stories mainly happen in the lab, and this shows two main stages of the lab. The first one is the prologue, and it's the original lab. And the next one is the epilogue. So this is how everything going lost control and how it looks like. So the future team could build their own from the visual guidance. And these are the authentic reference for the future team. So this shows things like layout and color palette and how a cyber future laboratory is going to look like. So we are Team Inklings, and we created motion capture and 2D and 3D combined animation called Ink Alive, and also a prepackaged called Seed for the future team. And thanks for watching, and we're open for questions.
Yes?
You talked about your dependency tree and how that made editing and reworking difficult. Did you research how other animation pipelines work and how they deal with the same problem?
Oh, thanks. So the question is, have we done some research on other animation pipeline that can maybe better fit our and solve our problems of the dependency list? So the answer is yes and no. Yes, is because we definitely have done some research at the beginning of the semester about how we gonna try to settle down our pipeline and do the whole shot. But the thing is, we in the middle of the semester we have done some major change on the storyboard. We dramatically changed our pipeline because we will try to add more 2D stuff into it. And at the time frame, at that, like we've done some research, and we've also done some research on our own skill sets, and combined with the time frames and the time we have left, this is the solution like we settled on because we think it's still manageable. There are not a lot of new things that we have to do research and to learn, and there are also a possibility to fail if we can't really do the pipeline that we found on the internet. So this is a pipeline we think we can do it, although it's a little bit tough and rough to do iterations and polish, but we can still finish the piece.
Any other questions? Yes.
Can you speak more about the hand pose improvements, the limited hand pose? Because it seemed that things that involved the thumb, you were off on, but things like opening hands to turn the page instead of grasping, you did much better with.
Oh, actually, I think the way, oh, sorry. Sorry. Well, it's now both open. I'll just. Wait, hello? Yeah, sorry for that. So I think for the page, the question is like how do we improve upon like the hand gestures? So there's two ways. Like for some hand gestures, we find like it's really difficult like to manage, such as page turning. It's really hard to match the hand with the page. We deliberately like change our motions. From previously, we just turn the page, use hand, but later we find it's hard. So because our main character is a witch, what about like just using magic to turn the page? That's the choice we made, so that the piece can look nice while also can reduce our workload. And for other things like when the characters pick up like the 2D turn book, like it's easy enough, and we want to show the audience it's turned to 2D, so we actually need the animation. So for that piece, we can put more effort and try to adjust the animation frame by frame to make it look nicer. So that's some of the choices we made, and hope that solves make the piece looks nice and still we can manage it in time. Yeah, thank you.
Time for one more.
Yes?
Why did you decide to go with like a realistic hand model instead of like a stylized?
Can you say the question again?
Why did you go for a realistic hand model instead of a stylized?
A style.
Yeah, I would say it's not that realistic as it looks like. So if you look at the textures that we put on, it's not that realistic, especially when we put it under the lighting. And also, we think it fits with the environment pretty well. So we didn't plan on changing it to more like stylized or semi-realistic style. Yeah.
All right, thanks, team.
Okay. Hello, everyone. We are Team Molten Core. We're working with the Rivers of Steel Heritage Corporation on an AR enhancement of their tour of the Cary blast furnaces down the river. So on our team, I am David. I'm the producer and also a 3D artist on the team.
I am Shinu. I am also the other 3D artist and the animator on this team.
I'm Tianyi. I'm the narrative and sound designer.
I'm Xing. I'm one of the 2 programmers.
I'm Eric. I'm the second programmer in the team.
You guys can... All right, so in terms of what we're building for this project, we want to create AR effects to empower the tour guides to tell the story that they want to tell on their current existing tour. So we want to maintain this historical accuracy on the current tour so that any additions will not impose on that in the tour. So we chose these 2 scenes. So on the bottom left, you can see this is the car dumper, and on the right, we have the cast house. So these 2 scenes we chose because we believe that they're the most difficult for the tour guides to explain and have the most potential for engaging effects. So our primary project goal is, again, to empower these tour guides and give them total control over their own tour that they give. We want to make these effects modular so that the tour guides can use some effects and not others, depending on how they decide to tell their story or depending on the specific guests in the tour. And on that note, we do want to design for all possible tour guests. So some effects are more playful, more engaging for younger guests, while other effects are more realistic for older guests or guests who have more experience in the field. And overall, we want to make the tour more digestible for all guests on the tour. So we start off with our scene 1 in the car dumper. So we'll start with the train coming in. I don't think it's playing sound. Okay. So we'll have our train coming in, and this is the start of scene 1, which the tour guide can speak to the weight of the ore on the car dumper. So we'll have the option for the tour guides to show this pile of elephants or a tower of Campbell's soup cans, for example, and these 2 effects can be used to illustrate the weight that these laborers had to shovel before the car dumper was invented. And these effects are designed to be more playful for perhaps younger guests, or if there's a more older tour in general, tour guides can choose to skip those. So we'll move on to this image of the laborers shoveling iron ore out of the car, and this is how the iron ore would have been transferred before the car dumper was invented. And so now we'll show the actual mechanism of the car dumper, which on our playtests, our tour guide said was the most engaging of all of the effects that we had. So if the tour guides were to pick and choose from their effects, they would all most likely show this one ultimately at the end.
For the second scene, it takes place in the cast house. Well, to get started, we can start showing this molten iron flowing down the trough scene. You can take your phone and walk along the trough. Everything will sync up pretty nicely, and that's pretty good. But how do we get from a bunch of raw ingredients into this molten river of iron? Well, the process is extremely hard to be explained by words, and it happens all inside the furnace, which is why we created a sequence of animations to visualize these effects. We start with coal, iron ore, and limestone. These are the 3 main ingredients that we'll be using. And first, we need to convert coal into coke. We can do this by heating up coal in the coke oven. After that, we can dump everything inside the furnace and fill it to the very top. Once we fill it to the very top, we can start heating up the furnace. The coke will generate enough heat and melt the iron. During this process, toxic gas will also form. So we want to choose a more artistic approach to showcase that carbon monoxide is extremely toxic to human. Finally, both the iron and the limestone get melted, and limestone gets turned into slag, which floats on top of the molten iron. Because of this property, we can tap the iron out of the furnace, and that brings us back to where we began.
Thank you. Okay, so to help solidify our ideas, we create a script. And once that script is created, we create a storyboard to help visualize our ideas and what we just created. And we highlight the augmented reality parts of our experience in blue, so that way we can know what we're actually making. Once the storyboard and script are finished, we send it over to our clients where we'll wait for their approval. So in this project, our 3D models had to be dimensionally accurate. So to do this, we went on site and took real-life scans of the cart dumper and the cast house. And then we got that point cloud and we converted it into a model, which we then imported into Maya as a very helpful 3D modeling reference. Once a 3D model is made, we send it over to Substance Painter, where in that program, we draw on a lot of, not just a lot of like the general textures, but also the rust, the dirt, and also just a lot of the overall realism in that on the 3D models. Other objects in our experience, such as the locomotive, the coke oven, and the blast furnace cutaway, also go through the same pipeline as well. The 3D models are then sent into Maya, once again, where this time they'll be having the animations applied to them, like this cart dumper animation you can see here. Finally, all the models, the textures, and the animations are all put into Unity, where they are assembled. And is this a video? Oh, wait, okay, so that's a video. But in this video, all the models, the assets, all the 3D models are assembled, and sounds are synced up and added to the whole entire experience using the Unity timeline. And then finally, everything put together, we get our final experience here. I'd just like to note about the UI that we make the buttons big and hard to miss, and also easy to understand on what to control, to once again give the tour guide that sense of modularity.
Next, I'll be talking about technical challenges and our efforts to tackle them. As you can see on the slides, we run into many technical challenges in this project, including AR markers, Wi-Fi connections, and rendering issues, so many challenges. And we managed to resolve all of them so that you see flow experience in the previous videos. Due to time constraint, I won't be able to go through the list. Instead, let's take a close look at one of the problems. As you know, the place used to be a factory, and there's no desk, no computer. So in our first visit, we brought our laptop, sat on the ground, and tried to manipulate the objects, the virtual objects. On the right, the cart actually was in the wrong position, wrong orientation, and we need to rotate by 90 degrees and put it on the track. Such a simple task turns out to be very difficult with the poor working condition. So here's our solution. Remember, we had a scanned model on the left. Then we made a simplified environment model on the right. Notice that the surfaces here is 400,000, but here we just have about 100 faces. So we call it base, and we use it like a stage. Then we put all the augmented objects, the train, the elephants, added to the base. and we fine-tune the positions, orientations, and timelines to make sure that all the effects, all the visual effects or sound play perfectly in Unity. Then when we go to the site, when we go during the on-site visit, the only thing we need to do is to make sure that the space matches the real space very well. So this is done by a calibration system. We created this calibration system so that we just adjust the position of the base by a few button click. Then we save it. That's done. So with this optimized workflow, we are able to do most development work in ETC and focus on playtest during the on-site visits. With that, I'll hand over to Tianyi to talk about playtest.
Okay, as for playtest, our experience works the best when you actually go to the furnace. So that's where all of our playtests happen. We've been playtested with 5 tour guides from our client team and about 3 tourists that didn't consist of 2 15 tourist tours. And we're glad to find out they're all enjoying our experience a lot. And here's the footage. Hope it works. During the playtest, our tour guides also gave us feedback that they love the way we designed the app, by which they can skip the part they don't want to cover and focus on different aspects based on their different backgrounds and different ways of storytelling. We've learned a lot from this playtest, and here are some few examples. First of all, in the originally we only have X, Y, Z calibration systems, but when we did our first playtest, we noticed that sometimes the train comes directly out from the ground, and that's why we added in the 2 angle tilting calibration system. The other thing we noticed is that the lighting condition makes certain effects hard to be seen, and that's why we came back and modified the light to make them all look good. Last but not the least, due to the lack of documentation, we highly rely on the experts' feedback from our client on the content accuracy, such as in this example, the dumping angle of the car dumper. So that's why the playtest is really important for us. Moving forward, we're going to hand off our build, code, and the detailed instruction to our client, and they will use this on the tours that's gonna happen in the spring because they're currently closed for the winter due to the weather. And this app will also be used for grant application. With that being said, this is the end of our presentation, and we're now open to questions. Thank you.
Is it made so that the client can add to what you have already created, or is this in total?
So this is, I guess this is a Unity project, and it's not too hard for our client to add things given the project, but they cannot do it without Unity. That's a short answer. I don't know if that's.
Yes, that's fine.
Any other questions?
So you talked a little bit about the difficulty of getting everything to line up, and you've got the calibration tool. What step first determines, what is your registration for your fiducial? How are you determining where to place the objects in space in there?
So we do have Fiducial Markers, which are the Rivers of Steel logo. So here you can see on the right the Rivers of Steel logo on site. And so we use that to scan it and position everything relative to that. One thing that we struggled with was that there's no real place to mount it. So we looked around for some good spots, and we found spots in both the cast house and the car dumper that were not intrusive in the total view of the site in case people weren't using the app, but also weren't so far away from the site that the calibration wouldn't work.
Is this deliverable now, and when will they start using it?
So there's a few more tweaks that need to be done Our clients will be testing it in the next week or two to see if there's anything that still needs to be done on the deployment side. In terms of use, the tours are closed for the winter, and they'll restart in the spring, which is when they're planning on using it. And we're trying to support their current hardware so that the app we've developed can run on their hardware instead of ours.
You said that if they're going to try to use it, but you're not going to be here in the next couple of weeks. You guys are all going to be gone. Who will be able to work on it?
Well, as for the next few weeks, we've made ourselves available remotely to help with deployment.
Thank you. Time for one more?
When you play tested with tourists, was that like actual random people who showed up to the blast furnace that day, or was that people that you recruited?
Yeah, so the actual tour playtest happens on the Saturday on week 11 and week 12. So that's like the last 2 tours of this year, and they are random people, yeah.
Yeah, so we did actually use 2 real tours. We got approval from all of them before the tour started to film and to show off our app, and they were all excited to partake.
Cool, thanks team.
Thank you.
Thank you.
extended or different?
I like this so much better.
Sorry for the chaos. Okay. Hello again, everyone. We are the last team today, Team Impression. And our project name is We Are Art Therapy. Heather and Ricardo is our, sorry for that. Yeah, so Heather and Ricardo are our project instructors. And here are our 4 team members. Lauren is a producer and artist. I'm the producer and UI UX designer. Thomas is our programmer, and Harry is the artist. Our end user is Tom Smith. He is our ETC alumni, and he is an art therapy graduate student at NYU now. And Dr. Ikuko is Tom's supervisor, and she also is the director of NYU art therapy program. Both of them are our collaborators. So we made prototypes and documentation and eventually delivered them to Tom. And Tom, this project will be documented for Tom's thesis on VR as another art medium for art therapy. And Tom's final goal is to use it and research further after he graduates. And Tom also wants to share this research with other art therapists in the future. The goal of our prototype is enable research of VR as medium for art therapy. So what is art therapy? Art therapy uses art medium, the creative process, and the resulting artwork as a therapeutic and a healing process. And it's always divided into individual and group sessions. For our prototype, we focus more on the group sessions. So the usual art therapy session is 45 to 60 minutes. Sometimes it's delayed to 90 minutes. For our prototype, we assume the people will use 5 to 10 minutes to get familiar with our prototype when they use it for the remote art therapy session. So next, I will deliver to Harry to talk about our project goal.
Thank you, Hui. So for our goal, we basically want to create a product that could provide new options for the therapy through VR platform. We want to expand the art therapy availability by putting therapy section into the VR platform. And also we want to replicate that real-life art therapy process as close as possible, which to maintain the therapeutic process on VR. So for our deliverable product, we will create a product that contains remote multiplayer space and also include an intuitive toolset for the R therapists to hold a section in VR. So in the end, we also want to give a product that includes both therapist and client mode for both participants to better get adept with the VR environment. The metrics that we use to measure our development process and the success through our semester development based on the three aspects. The first one is playtesting and user testing, which include multiple iteration of design and testing for different users from different backgrounds. Also, we have the documentation. We hold meeting with our instructor, our end user, and our therapy, and we record those meeting discussion notes to evaluate and implement the possible changes to our prototype. The third part is the art aspect, which include iteration of environment, the UI, and also the avatar in VR platform. So for half, we have achieved and strike several goals. The first one is definitely we have our basic first prototype ready and finished. We also have our platform and tech decided during that time. We have a really clear goal, but some goals and some small details were still unclear for us. So during that time, we need to reorganize our task list and focus on the primary feature that our client demands. So from have to solved, we start to work as a team toward a more clear set of final features for the product. And also we spend a lot of time to do the user testing and play testing. We hold a lot of sections for it and evaluate the feedback that we got from the tester. It was that time we seen if we can apply additional feature to our product based on the feedback, but we decided to cut other feature to focus more on the detail near solve because we want to deliver a more polished product to our end user. So for playtest and user test, we have done 25 total sections of playtest, which include 44 different people with different background. We have done 5 multi-brush, which is an existing tool that help us to iterate our prototype design. We have done 17 functional playtests throughout the semester. We also done 3 therapeutic playtests with our therapists and our end user. Next, I will give to Thomas to show the demo.
Hello, so we're gonna look at the demo now. We can't get video to stream from the headset to the computer, so we're gonna watch a video, but our final prototype is functioning as shown. So the first thing a therapist will do is select their role in the main menu and then choose their preferred professional name that clients should see. For clients that are completely new to VR, you might explain the headset on Zoom beforehand. And there's a built-in Oculus voice chat that you can use to talk remotely, even if people are in different, are remote from each other. So as you can see, the therapist and client can see each other in the space, and this is our virtual space. The client starts out at this desk, and the first thing that happens in a therapy session, and we witnessed this in our mock sessions that we did with with Tom and Ikuko, is that there'll be a discussion and explaining what art therapy is. Following that, we need to move the clients to somewhere they can draw. We have a table for drawing seated. We have a plane on the wall for drawing standing up, and we have easels for individual drawing as opposed to one large plane. So right now we moved the client to the wall, and then they can see, at this point, they can see their drawing tools and start painting. So usually the therapist will give a prompt, maybe like draw your house or something meaningful. And drawing, the prompt could take between 10, 20 minutes usually. So our drawing tools, you just press the trigger to pick up the brush, and then you touch the brush to the canvas and you press the trigger to draw. You can select different colors using your color palette. Yep. So once the drawing time is up, you can either go into the discussion or you can advance to a new prompt. But let's say we were doing multiple prompts, which sometimes happens. We can move the client to another spot. In this case, we went to the easels and give a new prompt like draw your family or like your hometown and go into another drawing session. So again, like the goal of art therapy is to make drawings that might be meaningful and then discuss them and find, therapeutic insights. So once the drawing session is done, you go into this discussion portion. Where this is like the most therapy-like part where you discuss what the drawings meant. You can also, the therapist has controls to erase the canvas and save paintings as images in the headset's files. If you want to track the progress of a client over time or save them for later, maybe send them to the client. So at the end of the session, you may want to move the client back to the table where their painting controls will disappear again, and you can have a final discussion without any further distractions. Maybe if there's more distractible clients, this could be helpful. Once the therapist and client are done discussing the art, then the session concludes and you take off the headset. All right, now let's talk about the changes we made from softs. So we got a lot of good feedback in softs, and we made several changes in response. We added a canvas texture. Our canvas used to be just a blank white field, and we added a texture, and this helps with depth perception and helps you not get disoriented if you're right next to the canvas. We also just added more decoration to the room to make it feel more real and not so bare. We have abstract art in the wall paintings, which helps clients be comfortable just trying to draw something, even if they feel that they're not good at art, because the abstract art is similar to something they could draw without prior experience. We also allowed clients to move with the joystick. So both therapists and clients can move with the joystick, but clients can only move within a fixed boundary based on the location you've placed them. So they have freedom to move if, for example, they can't reach the canvas, or they're sitting in a chair and it wouldn't be comfortable for them to stretch out. But they can't wander off. The therapist still has control over the flow of the session, what zone the clients are in and what they're doing. Make sure they're doing what they're supposed to be doing. Finally, we changed the spawn location to prevent therapists and clients from spawning on top of each other. And we also added a safety system to fade clients out when they're intersecting each other so that they don't feel uncomfortable. And then finally, we added the feature to save the canvas as an image because this was requested by Tom and Ikuko. All right, now Lauren will talk about the handoff.
Yeah, so Tom already has and has had full access to this app. Now he has full ownership, so he can also share it with whoever he wants to. And we're also passing off all this documentation so that he has an in-depth enough understanding to teach other people how to use it or to get another development team on it to do more work. So with this project behind us now, we've learned quite a few things. One is that it's important to incorporate intermediate designs early on. A lot of times we'd sort of over-design things when we should have just put it in the prototype and play tested it, since we were already scheduling so many playtests. Another major one is sort of taking a client's specific requests and knowing how to ask questions to figure out what the underlying need was. A lot of times we can actually come to a better solution as a group with more perspectives involved. And lastly, there were a lot of takeaways from playtesting. One is that playtesting comfort is a lot more hard than we thought it would be, mainly because people don't really notice it, and you have to be very specific with the questions you ask. And we also had to make a lot of compromises to sort of playtesting rules of thumb. We actually avoided naive playtesters for things that involved Tom and Ikuko because they were already kind of semi-naive to our prototype. So in summary, we've been building a prototype platform for art therapy in VR and creating a remote shared virtual space for collaborative art making. And through a long process of playtesting, we've made sure that it's very flexible for the therapist to run a session the way they want to. It's comfortable and usable, and it's a strong foundation for future inquiry into this area. And as additional thanks, we'd like to thank Tom Corbett and Jesse Schell for being faculty consultants, Brenda Harger for pitching this project in the first place, and Tan Yutao for our sounds. Thanks for listening, and we're now open to questions.
Yeah, did the users feel like they had the control they needed to paint? Was there any frustration with the UI or the UX along the way?
The question was, did the users feel like they had control over the paint?
Yeah, for the most part, users felt like they went right into it and drew, I guess sometimes I might say without thinking. So we didn't often get like additional feature requests. Some I would call them power users asked for like more complicated color palettes and other features that you might get in like a digital art software. But we felt like that, making the feature set more complex wouldn't be appropriate because it would be a trade-off. It would cut down on it would increase the entry barrier for more naive guests. And we want the app to be accessible to everyone. Like accessibility is one of the most important traits of the app. So that's what we prioritized. We kept the feature set pretty simple. But we have some features like the width of the brush stroke changes depending on how deep you put the brush into the canvas. And most people feel like they are really doing something similar to painting, and they draw what they intended to draw based on our user tests. Yes,
you
Mike?
talk about this as a tool for group art therapy. Can you talk about group size, and also were you able to play test with groups and learn about group dynamics?
Yeah, so we've tested with, I think, up to 4 or 5 users together, definitely 4. So we've tested with like at least 2 therapists and 3 clients. So the prototype can handle it. And what generally happens during those sessions is people stand next to each other. They're automatically spaced out. And then they can either draw next to each other, for example, on the easels. You move them there if you want them to make individual drawings. Or you can ask them, sometimes Tom and Ikuko ask people to make a collaborative drawing, like an exquisite corpse, or like draw one half of something and then switch sides. So they definitely appreciate the collaborative elements, and they have tried it in our user tests with like the mock sessions. So did that answer your question? Sorry.
Yeah, I want to know about collaborative versus parallel behavior.
Yeah, so we've done both. Tom and Ikuko have made clients go through both, and it's possible to draw simultaneously on the same spot, and things work relatively robustly. So, yeah. Thank you.
You may have said this already, I might have missed it, but did you say that this will be used right away with your client? Your client is going to be...
Yeah. So to clarify, this can immediately be used in like a real art therapy session. We've been doing practice art therapy sessions already.
Cool.
One more?
It's very interesting, their experience. I just have one technical question. In a physical space, when you draw something, you have a physical board that stops your pen go further. And how do you do that in VR?
So there's a certain degree of constraint where even if you go through the canvas, your pen will stop beforehand. So that you can't physically stop the hand, but it psychologically suggests to the user that they should like slow down at this point. If you went like a foot in, you will eventually just pop through the canvas. But clients don't do that. They feel the vibration and they see the feedback of drawing, and they stay near the surface. It's also the depth has more influence because it affects the width of the brush. So clients are focused on actually manipulating how deep the brush is in order to draw realistic strokes. So they don't mess with the system because they're interested in painting. Yeah.
All right. Thanks, team.
Thank you.
Okay. Congratulations to all teams who win today. Good job. We'll see the rest of you all tomorrow back in the Let's Go Great.
During your fun, Zoom, either Zoom, right? Yep.
I'll see you on Zoom, bro. Yeah.
I know that must have been disappointing, but the video was a good save. I'm just gonna say that video saved your butts, so I'm sorry about the. Yeah. I was feeling for you, I was like.
It works every time, but like the final moment.
Of course,
it doesn't
of
work.
course.
Of course it happens.
Yeah.
But I have experienced that all the time. So.
Good recovery. Misuse this.
Yeah, I used this one, but I used this one, so the purple jumped.
I'm wondering if whenever you had your HMD hooked up, if it's showing up on Windows as a third display. Because now that we've unhooked it, as soon as I put it into presentation view, it brings up the view properly.
Is there any way?
Well, had we have known you were doing a live demo, I would have recommended that you bring down a separate PC that you would plug your HMD into. And then we'd plug that into one of the spare inputs on the lectern. So you would have presented off of the lectern PC and you would have demoed off of the PC you brought down from your room. So that way they would have stayed separate from each other.
I don't know how it works.
Did you present off, did you hook the Quest up to the lectern during
Yeah, we
demos?
did it like this.
We did.
Yeah, the other thing is, and you know, this is on us for not reminding you all, but whenever a team has a fancy live demo they'd like to give, we typically tell Drew, and he puts that team first, so they can come in before presentations start and get the demo ready to go. So that way, when they come up, it's already ready. They just put it on and go, and then when they're done, they can clean it up and get it out of the way. So, I mean, that's on us. We should have reminded you all, but in an ideal scenario, you would have gone first today, and you would have come down here at like 12:30 or whatever, got everything perfect. So that way, it's just sitting there ready for you when you come up and needs to go.
Yeah. We have a
Yeah. So next semester, for the spring semester, if the teams you're on have demos, we'll make sure to get it all perfect. Well, to start up, the hotkey in PowerPoint for slideshows is F5, and if it comes up flip-flop like this, you go to display settings and you just do swap presenter and notes view. But the problem we were having was whenever you were starting your presentation, you were getting nothing here, and your slides are over there.
Yeah.
So what I'm thinking is somehow when you were unhooking the Quest, it showed up in Windows as a third monitor. So your notes were popping up, but they were on the Quest. So, but it's just at that point we were already 5 minutes in of, technical difficulties, and we just needed to start.
Is this ours?
Yeah. You got both cameras?